Hi everybody. So here we've got a past exam question involving implicit differentiation. We're given this equation of a curve and we need to find dy by dx. And then for part B, we need to work out the exact value of a gradient of the tangent to the curve at point P. And we're told that P lies on the y-axis. So do you want to try and give this question a go yourself? You can pause the video and when you come back, you can check you're working with mine. Okay, so welcome back. How did you get on with that? To find an expression for dy by dx, we need to differentiate each of these terms with respect to x. So when we differentiate 3x with respect to x, we'll just get 3. And if we want to differentiate with respect to x 5y squared, then we need to differentiate it with respect to y. And then we multiply this by dy by dx, because what will happen is this dy will cancel with this one, and we're left with the derivative with respect to x of 5y squared. So we differentiate it with respect to y, and we get 10y, and then we multiply it by the dy by dx. And to differentiate the 4x squared y with respect to x, we need to use the product rule. So if we let the u term equal 4x squared, then we'll let the du by dx term equal 8x. The v term will equal y, and the dv by dx term will equal dy by dx. So we'll have du 4x squared multiplied by dv, which is dy by dx, plus the v term multiplied by du by dx, so 8xy. And this will equal, now we need to differentiate the t to the power of x term. So if we now let's say let y equal t to the power of x, then because this x is a power, we need to take the natural log of both sides. So we'll have a natural log of y will be the natural log of t to the x. Now using the power rule, we can bring this x down. So we'll have the natural log of y will be x times the natural log of 2. Now if we differentiate both sides with respect to x, the natural log of y will be 1 over y times dy by dx. So I've implicitly differentiated this. When we differentiate the x ln 2, well, the x will go, and we'll have the constant ln 2. So dy by dx will move this y over to the right-hand side, and we'll have y ln 2. But we know that the y is actually 2 to the x. So what we'll get is 10 lots of the y term, 2 to the x, multiplied by the ln 2. And when you differentiate by 35, that's a constant, that will just go. So we can tally up what we've got here, and I can factorize out the dy by dx. So if I write that bit first, dy by dx multiplied by the 10y plus the 4x squared, and then I can move the other terms, the 3, that'll be 8xy, to the right-hand side. So we'll have 10 multiplied by the ln 2 times 2 to the power of x, and then we'll take away the 8xy, this term here, and we'll take away the 3. Now we just need to divide both sides by the 10y plus 4x squared. So dy by dx will be this left-hand side, all divided by 10y plus a 4x squared, okay? And then for part B, the curve cuts the y-axis at point P. So at P, we know x is 0. So if we substitute 0 into here, we'll find the value of y. So therefore, we'll have 3 lots of 0 plus the 5y squared. When you substitute the 0 into here, all of this will become 0. We'll have 2 to the 0, which is 1. So this term will just become 10. And then the 10 add the 35 will become 45. So 5y squared will equal 45. So y squared will equal 9. And we know y is greater than 0. So y must equal 3. So at P, x equals 0, y equals 3. Now we can work out the gradient. So dy by dx. We'll substitute in the 0 for x here. And we'll just get 1. So this will become 10 ln 2. When we substitute in the 0, this term will go. So we'll just get negative 3. Divided by, we'll have 10 times 3 to make 30. And this term will go because x is 0. So this will be the exact value of the gradient at P. Okay? Well, thank you very much for watching. I hope you found that useful. If you want more practice on implicit differentiation, you can download the worksheets and the lessons from my website, mrmathematics.com. I'll leave a link in the description below.